Alright, ladies and gentlemen, in this video segment, I'm going to show you how to use Newton's second law in order to solve for either force, mass, or acceleration. Okay, now in this video segment, the problems are going to go by a little bit faster. I'm not going to read off the problems themselves, so feel free to pause, read the problem, maybe copy down the problem if you want to, and unpause it to see how I actually do the problem. Now if you get a little bit comfortable doing these, pause the problem before I actually solve them and see if your answers and your work matches up to mine. Alright, let's go. So in this problem, I'm going to show you what I always start off the problems with. Okay, I always start off the problems by writing down the variables that are given to me. In this scenario, the acceleration is 2 meters per second squared and the mass is 3,000 kilograms. The question is asking for the force. So I write down Newton's second equation, F is equal to ma, put in my variables, 3,000 for the mass and 2 for the acceleration. I'll multiply the two together to get 6,000 newtons. Okay, second problem. Just like the first one, I'm going to start off the problem by writing down what the problem gives me. The problem gives me the mass is 10 kilograms and the force is what it's looking for, and the acceleration that is given is 3 meters per second squared. So with that little bit of information, we have F equals ma, plug in 10 for the mass and 3 for the acceleration to get a total of 30 newtons. Next, in this scenario, we have a mass of 2,000 kilograms. And a little bit different, this one gives me a force of 5,000 newtons. So you're not finding the force in this scenario. Now we're going to look for the acceleration. Okay, using the equation F is equal to m times a, we have the force is 5,000, the mass is 2,000, and well, we don't know a, so I'm just going to write down a right there. Then I'm going to divide both sides by 2,000 in order to get a acceleration of 2.5 meters per second squared. Okay, 2.5 meters per second squared. Alright, in this one, I'm looking for the mass. So I give you the force of 14,000 newtons. And I give you the acceleration of 5 meters per second squared. Now, I'm asking you to find the mass. Okay, so we have F is equal to m times a. We have F of 14,000 newtons. Okay, and we have the acceleration of 5. So I put in the acceleration and I put in the force of 14,000, and I use a calculator to do 14,000 divided by 5 to get 2,800 kilograms. Yes, ladies and gentlemen, the standard unit for mass is kilograms. Alright, in this problem, I'm going to start off actually by drawing a free body diagram to help me out. Okay. Now, it's not given in the problem, I missed that little note, but the weight or the force of gravity, can remember they're interchangeable, is 80 newtons. Okay, the weight or the force of gravity, both the same things, is 80 newtons, and they both go down. We have 50 newtons going towards the right, and the force of friction always goes against movement, okay, is shown by going to the left. I'm going to start off the problem by looking for the normal force, the force that is perpendicular to the surface. In order to do that, I create a F net equation in the y direction, and I know that in the y direction it's not going up or down, so my F net is in fact 0. So we have F of g, which is negative 80 because it's both going down. Okay, and we have F of n, which is positive, and it's going up. I subtract f of n from both sides. Now you don't have to do this. You could simply add 80 to both sides and find the same answer, but I decided to go the extra long step. So I subtracted the normal force, or f of n, from both sides to get negative f of n is equal to negative 80, and I just divided out the negative 1 from both sides to get normal force is equal to 80 newtons. Alright, now to find mass. To find the mass, we're going to use our newfound information to find the mass. We have F is equal to ma. We know that the normal force, or the weight, excuse me, the weight is 80 newtons, okay, 80 newtons going down. Now, I should have put in a negative there, but I forgot, I'm sorry. And then my acceleration due to gravity should be a negative 9.8, okay, so when you copy these down, please make sure your 80 and your 9.8 are both negative. Now, luckily for me, when you solve it, you'll still get the same answer of 8.16 kilograms. Okay, when you do it right, the negatives should cancel out. All right. In the next problem, we're going to look for the acceleration of the object. Okay, so we have the mass, and we are looking for the acceleration. Now it's moving in the x direction. So we need to find the F net in the x direction first. We have 50 minus 10. Now it's minus 10 because it's going towards the left. Okay, and we get a F net of 40 newtons. Plug that into F equals ma. 40 is equal to 8.16 times acceleration. Divide both sides by 8.16, and we get an acceleration of 4.902 meters per second squared. And that's about it, ladies and gentlemen. Thank you.